Okay, first of all, I have some announcement very quickly as a reminder. Over here, so if you're still on the waiting list, you're not officially registered, I have no power to add you to the course officially, but I can add you to the Moodle site so you can complete the labs. If you haven't sent me an email about adding you to the Moodle, send me an email, okay? For lab number 0, it will be due tomorrow. If you already completed and submitted it remotely, that's absolutely fine. We do not take attendance in the lab. It's mainly for you to go there and get helps. That's the main intention. My office hours will start this week, 4 to 6 p.m., Monday, Tuesday, Wednesday. If you have any concern about the course, speak to me, okay? And then I keep emphasizing, so if you're really feeling your lack of the background knowledge about Java, basic programming, classes, objects, loops, if statements, that tutorial series on the slides, and also in the pre-study material, that will give you a very thorough introduction, okay? If you got any trouble understanding anything, speak to me. Okay, the plan for today, I would like to still continue to review the basics about Java, especially classes and objects, because later on, when we talk about advanced concepts, it really depends on that. I want everybody to be on the same page. We might still continue with the review just a little bit, maybe about 1/3 of the next class on Wednesday, and then we'll move on to new topics, okay? That's kind of the plan. So now let me start with where we left off from last time, okay? So this is the kind of a fragment of code, very simple just for me to illustrate and review many concepts. Basically, we define a class called person, and then we got 4 attributes over here, and then we show you on the Eclipse, every object of type person is going to have 4 fields, right? 4 attributes over there. And then what we try to default constructor. If you define no constructor in your class, there will be a default one implicit there for you to use. On the other hand, as soon as you define some customized constructor, you will overwrite the default one. Okay, that's what we went through last time. I want to continue from there, okay, and then continue to build and see more interesting methods. Now, I have a question for you, okay? You can see that at the moment, for example, you can see we have an attribute called age over here. And then we have a parameter input, parameter for the constructor called new age. And then correspondingly, we have an assignment over here. This works pretty well from what we can see last time, okay? However, let me change the following, okay? Rather than having just new age, okay? I'm just going to do age, which means the input parameter name has the same name as the attributes. And then I'll change accordingly the new age over here to be just age. And you can imagine similar changes to other input parameters. Anybody clear about the change I'm trying to make over here? I'm just trying to clash the names between the parameter and the attributes. Now, number 1, is the code going to compile? It is, right? Which means you have no write cross. So if you submit this code for lab test, you wouldn't get an immediate 0 because there's no error. However, you might get 0 anyway because that's not the correct program, right? So we want to understand why this is not correct, okay? Basically, let me, a few things we really have to understand too. Number 1, you can see that we have a clash. You can see age over here, left-hand side of the assignments, right-hand side of the assignments, and also the attribute name is age. So we got 3 things over here. So now, question for you. This age over here is referring to which age? Is it referring to this age over here? I'll give you a number. Is it referring to, I'll make it a little bit thicker. Is it referring to age number 1 or age number 2? I heard 1, okay. Okay, so it turns out it's referring to number 2. That is why it is bad. The reason is, given that we already have a parameter over here called age, so now you can imagine, so this is something called shadowing. You can imagine that, think about the age over here, it's like umbrella, right? It has already covered the attribute that's actually over the sky. So we cannot actually see the attribute age anymore. It's already covered. So that means this age over here is really referring to the age over here. That's the problem. So what we are actually doing over here is to change the parameter value over here by itself. That's not what we intend to do, agree? That's why it's an error. So shadowing, so this will give us some so-called logical error, which means we have no compilation error, but the program is not going to work the way we expect. Okay? So it's a logical error over here. You're basically assign input parameter to itself. Everybody okay with this error? If I ask you this in the lab test, you should be able to understand, right? Okay, number one. Okay, number two. How can we resolve this? Because having to come up with new names, like a new age, new weights, new heights, so that we don't have any clash with attributes, it's not really very flexible for us as a programmer. We want to be as flexible as we can. There's nothing wrong of calling this age over here, as long as we can distinguish the age at the global level, the class level, and the age at the method level. As long as we have a way to do that, then that'll be okay. And there is a way. Okay? It's so-called this keyword. Okay, you may have seen this keyword in 1022, but I just assume maybe just review a little bit and give you a little bit introduction, and reinforcement might be nice. So this keyword basically is implicit. Let me just mention this. Every time when you are trying to do let me just talk about this keyword in the next slide. That'll be easier. Okay? So now I want you to understand you only have to use this keyword if you have to distinguish between the current objects and also the parameter. Okay? That's kind of the context, the most common context you have to use this. Normally when you see other people's program, they don't really have this. Normally they don't. But I'm going to use this in the next slide, next example, just to show you how you can visualize the object and trace the code. Okay? But for this, the lesson we learned from this particular example is, if you simply got shadowing, it's going to give you the wrong behavior. Okay? That's the lesson. So now let's go to something very similar. Okay? Similar, but not quite the same. So now let's look at what we have done here. First of all, you can see we got age over here. That's the parameter name I want. I don't want to come up with new names. Age over here, it seems like we have clash. It seems like. However, the way we get around with that is by disambiguating which age I'm talking about. The way to do that is by simply say this over here, and then this is without a this. Okay? Let me make a note for you. If I have this.age over here, this is referring to the attributes, which is this. Okay? And then if I don't use the this, it's going to do according to shadowing. It's going to refer to this age. So now I'm actually doing what it is supposed to do. I'm trying to change the attribute age by the value of the parameter. It's a very brief story. And then I need to trace the code in detail to make sure you really understand. You're going to use this keyword in some other context as well. Okay? So now let's try to trace the code a little bit. So now having this over here, let me just undo a little bit. Okay? I want to clear this up. Okay? But if you want to get the notes, you can watch the recording just for that part. Okay? So now what I want to do is to trace this piece of code, how exactly it works. So you can see why this keyword is useful. Okay? So now in order to trace the code, let me trace on the paper first, and then we're doing iPad. Okay, we'll do both. And then we'll do it on Eclipse. We'll do both. Number one, let's go over the tester over here. Basically, it seems like we are trying to call the constructor of person twice. Right? Basically, every time when you see the new keyword, that means you're trying to create a new object. So now we are trying to create two objects, two distinct objects. Okay, let's try to trace it. Number one, let me be consistent with the color over here. Number one, let's say we're doing line number one. What does it really mean? When we try to say person, Jim is assigned to new person, and then 45, 72, 1.72. What does it really mean? I would like to break it down into three parts for this assignment here. Okay? So now the first part is going to be just here. Okay, you can see just a new keyword over here. Let me call that number one. Okay? And then the decoration of Jim over here, I'll call that number 2. And then the middle assignments over here, I'll call that number 3. This is the complete way to understanding this particular creating new object. You see that a lot in Java. Okay, we got 3 steps over here. Number 1, because we are using the new keyword, that means we are creating a new object. And now let me show you only the first time, only once. I want you to understand how to understand the pseudo address that we saw last time in Eclipse. Remember we got some person at some funny character over there, right? So that has something to do with memory, okay? I'll just give you a little bit lower level detail, just a little bit. You know, we got computer memory, and computer memory is simply a sequence of bytes for us to store information. And depending on what kind of data you store, for example, if you try to store integer, it takes 4 bytes. If you store double, it takes more bytes. Okay, you don't need to know the exact number of bytes, but it takes some bytes to store every type of information. So now let's say this is your memory, which will, each memory cell has kind of like an address, right? That's how you can get access to the memory, like an array. So now I would like to do the following. Let me just make up some address over here. Let's say this particular address is simply 061101. Okay, just like a memory address. Okay. On the other hand, let's say for this one over here, okay, this one, I don't have space. Let's say it's 0x, I don't know, 2034. Okay, I'll just make it up. Okay, just distinct memory addresses, 2. Now, since I'm trying to create a new objects, what the Java runtime would do is go into the memory and allocate some new space that's unused. And then let's say this is what they can find. And they can realize you got to store 4 information over here. They're going to store 45, 72, 3. 45, 72, 1.72. And not only that, because you got 4 attributes, also the string over here, right? Depending on what kind of data you're talking about. Because now we're trying to store information for person, so you need 1, 2, 3, 4 information. And then, how does this work? So what it will do is it's going to go for 45, 72, 1.72, and do the corresponding assignments. And now, how do we trace this particular block of code? I'll write it down. I'll put it down here. So it's new person over here. And then we got 45, 72, and then 1.72. How do we trace that? So now think about this is a usage of the constructor. In order to see how the usage is being executed, you have to see its definition. Where is definition? Over here. So this is the definition for the constructor. Okay? And then we are saying that for this particular age we're expecting as the input, now we're going to put 45. So now every occurrence of age is going to be replaced by 45. For this particular instance, 45, okay? And then 72 is going to replace every occurrence of weights, 72 and 72. And every occurrence of heights is going to be replaced by 1.72, okay, 1.72. Everybody okay so far? Okay, now let's look at how this should be interpreted. This basically talk about context objects, or just the current object that we're considering. At the moment, we are basically considering this particular block of memory that we're trying to fit in for the new objects. So that's the context objects. And we are saying that for this particular object that's over here in the memory, we're going to find out its age field. Let's say that's the first one. And then assign 45 to it. And similarly, for weights, which will be the third one, you're going to assign 72, and then 1.72. And then it will simply be null for nationality. Right? You can see that how it is traced. Okay. Question, please. You're good, right? Good. Okay, that's how we do number 1 over here. What about number 2? So number 1, simply set aside some memory location and put in the data, right, according to the arguments. Number 2, we are trying to declare some object variable or reference variable. So now we declare Jim. So this is number 2. So I should put number 1 over here. We just allocate the memory and fill in the data. Number 2 is We are trying to declare Jim to be a variable. But what does Jim store? He only stores the address. So that's something you got to be careful. In object-oriented programming, when you have a reference variable, the variable only stores indirectly the objects. It does not store all the contents of the objects. It does not store 45. It does not store null. It does not store any one of them. It stores only the starting address of the objects, which is here. Okay, I'll put it there. So what it will do is it's going to put 061101. You can put it there. That's all it does. Okay? And then after this, oh, actually, I kind of go a little bit ahead. Let me say it again. When we only look at number 2, we're only declaring Jim, and we know that Jim is only going to store an address of type person. And then when I move on to number 3, the assignments over here, that assignment is going to copy this particular address and put it there in the variable. So that's going to be 061101. That's the complete process. Okay, that's how it works. And if you program in C or C++ or some other a little bit lower level language, they allow you to actually manipulate the address of the memory or to allocate the memory at the runtime. However, that's not allowed in Java. But I think that's just enough detail for you to know. That's kind of a very low level for you to trace the code. So later on, I'm going to use other notation. I'm simply going to draw arrows and boxes. Okay? You can think about conceptually. That's what I'm going to draw later. Since Jim is actually storing the address of this starting location of this block of memory, conceptually, you can think about Jim is really pointing to this particular object of type person. And then under which you got all the 4 attributes with different value. That's how I'm going to draw. I will show you one example in just a moment. Okay? So now let's do something very similar. Okay? I wouldn't repeat the entire process. I will just want to show you just enough. So now after this, we got Jim being set up. What about the next line? You can see the next line, we are trying to basically call the same instructor over here, right? We just say new person over here, and then it's going to be 62, 65, and 1.81. Okay, we're just making a second call to the same constructor, so a second usage. But we're going to refer to the same definition. We're going to do similar tracing. I'll show you just one parameter. So now you can see now, for the age parameter, we're going to replace every occurrence of age by 62 in this case, right? So it's going to be 62 over here and 62 over here, orange, as opposed to pink, right? Just different usages. So what you end up having, let's say this is the memory location we are talking about, and then we're going to get, in this case, 62, and then null for nationality, and then 65, and then 1.81. Okay, that's basically number 3. This is number 3. Sorry, number 1. Let me be consistent with the number. That's the first step. What about the second step? The second step, we are just declaring Jonathan to be a person reference variable, which means Jonathan is also going to store an address. And now, which address is going to store? Well, this one here, right? So I'm going to copy that, and 0x2034. That's the address. So now conceptually, you can think about, first of all, these 2 addresses are completely different, simply because we are talking about 2 different blocks of the memory, right? So they are different objects. So now if I simply say Jim equals Jonathan over here, it will simply just be different. It's very easy to see because we are trying to create 2 different objects. Of course, the addresses will be different. Okay? Questions? This might be the only time I'll draw some memory diagram to show you, but later on we're going to see a much easier way to trace, and you do need that for later code. Questions?
If I did Jim equals Jonathan, even with the same values but different addresses, it would still be...
Yeah, you're talking about, I mean, Jim, sorry, let me do it again. Oh, let me just say one thing. So here, I didn't mean a single equal. I meant equals equals. Sorry about that. Okay. Let me just do make a note over here. And then you can maybe ask your question again. Let me just disambiguate this first. So now if I say Jim equals Jonathan over here, we know that this is a relational operator. It's comparing the two addresses. This is simply just going to give you false. Okay, number one. Number two, if I write what I used to write, for number two, if I simply write Jim is assigned to Jonathan. Okay, I'm actually going to talk about this separately in detail, but to give you a very quick preview, what this will do, anybody want to tell me? What is it going to do? Yeah. Yes, exactly right. That's going to store the address of Jonathan to Jim. So now I have a question for you. Okay. So now, since I already drew some diagram over here, remember Jim has been created using this box, and now Jonathan, of course, is pointing to a separate box. Okay. Okay, just a different box. So basically, Jim is an object, Jonathan is another object. So now, can you tell me how am I supposed to change my diagram so that it's going to reflect this particular reassignments? Should Jim now point to Jonathan, or should Jonathan point to Jim? Jonathan point to Jim, right? Okay, because Jonathan is now stored the same address. So Jonathan now, rather than pointing to where he used to point to, is now going to point to Jim. They point to the same objects. And it's something called aliasing, which I have to review as well, quickly. Guys, are we okay with this? What am I talking about? Absolutely. I don't want to create confusion. Let me do it again. Jim is pointing to this object of type person, and Jonathan over here is pointing to another object of type person. So now the question is, if I say Jim is assigned to Jonathan, okay, whatever that is stored in Jonathan, we're going to copy that into Jim so that both of them point to the same object. But which object should it be? Okay, so now because it's Jonathan that's being copied, right? So that means Jim right now, rather than pointing to its original objects, is now going to point to this one here. Okay, thanks. Okay. Guys, are we good? Yes, questions? Correct. So basically, okay, think it this way. After this occurred, Jim and Jonathan both refer to the same objects. That means right now, if I do something like this, if I do Jim dot, let me say let's say this. Let me say the weight used to be, let's say 72, for example, right? If I say Jim dot get, let's say gain weight. Let's say 3 kilograms. Number one, when you see dot, whenever you see the dot notation over here, dot simply means look up the address that is stored in the context object, in this case, Jim. Go to that memory location and modify the objects, right? In this case, Jim dot is going to show you it is this object that it is trying to modify, right? And then we are trying to change the weights by 3, right? That means we're gonna do like that, okay? So now a question for you. Immediately after this line, what if I say print line? Jonathan dot, let's say get weight. What would that be? Would it be 72 or 75? 75, right? You can see that's an interesting thing about aliasing. Even though I try to gain weights on Jim, it will be reflected on Jonathan as well. This happens simply because they both point to the same objects. Okay? We'll see aliasing more. So aliasing, in its simplest definition, multiple copies of the same address. Okay, that's basically the idea. And now using either copy to modify that object is going to be reflected on all the other objects, all the other addresses, all the other copies. We're going to see more. Okay, I promise you will see more. Yes?
So whatever the original data was at the gym object is now overwritten.
Very good question. What happened to gym? Let's say after this particular assignment over here, that means we discard this original pointer, right? So now what happened to this particular objects? It depends. If there's no other pointer pointing to it, there's no other variable storing its address, there's something called garbage collection, which is done automatically for you by Java compiler. By Java runtime is going to take care of that. If there's any other variable that's storing the address for this one here, it's going to remain there over there. But gym is no longer pointing to there, so that's not your concern.
So in case there is something pointing to that, and you use the same method you did on gym, the gain weight, then that one would be appended as well.
Yes, so basically like this. Okay, interesting. How about I give you another example? Say you want. Okay, let's say we try to create a new person. Okay, let's just talk about age. How about that? Okay, we'll make it a little bit simpler. Let's say Alan, 62. $45. Okay, let's say just age. Okay, and then we got another person over here, Tom. Okay, so far so good. We'll try to trace the code together in just a moment. Let me try this. First of all, let me say get older, simply increment the age by 1, let's say, just grow older, okay? Tom.h. Okay, this is not that complicated. I'm just thinking on my feet. Okay, I do have something that's more complicated for you. Right? Let's just go over this quickly. Okay, now let's say without drawing anything, can you tell me what the output should be, and then we'll verify that. The first one, Alan.h. Okay, maybe not too bad. Mark.h, 46. Error? There's no error. Okay, I heard 67. This is a little bit hesitant by everybody, right? A little bit, okay? Maybe you're right. What about Tom.h? That might be similar to the example you're talking about, maybe similar, okay? Let's try. So now also I can show you how you can trace the code. Before I'll go back to this in just 1 minute, okay? I want to show, I do have one slide over here. How do you visualize objects? That's exactly the scenario for you to practice. I'll give you some example question I used to use for 1022 exam that will also help you strengthen the understanding about aliasing. So this is a principle, you can find it in the slides as well. When we talk about tracing object-oriented code, in a simple example like this, I would say we can get around, just thinking in our head, that's not too bad. But what if you got arrays involved? What if you got 5 objects involved? What if you got 6 different assignments tracing around? In that case, you have to maybe need some tools to help you, drawing tool. So now let's see how we can visualize an object. Let's do that quickly. Basically, every time you want to draw an object, use a rectangle box like this. And then put the title, which is in person. That means we are having a person objects. And then you have the left column, these are all the attributes for that particular objects, right? Depends on which class you're talking about. If the class has 5 attributes, you got 5 columns. You got 5 rows in the first column, okay? And then the right column is going to tell you the instance-specific value, object-specific value. For example, for Jim, it's going to be 50, British, 80, and 1.8. Yep. Example. And you can now see I'm just simply drawing arrow simply because Jim stores the address of this particular object in the memory. But for convenience, we simply use an arrow to draw. Okay, that summarizes how you are supposed to draw a diagram. Okay, practice that. I'll draw lots of diagrams, don't worry, throughout the course. Okay, hopefully you'll practice. Go back to this. Let's apply that right away. Okay, for simplicity, let's assume there's only one attribute for the person class. So we got our class person over here. And let's say there's only one single attribute called age, only a single one, okay? That means every rectangle box we draw for a person should have only one row, age, okay? So now let's say, how do we draw this one? First of all, new person, so we have a person over here, person objects, put a title over here. There's only one single attributes, right? And then it's gonna be 62. And who's gonna store the address? Alan, pointing there. Okay, arrow is really important because arrow gives you the potential of changing the address around. Okay, second one, similar. You also get something like this. You got person, the same object, so the same title. And also age, 45. And also that should be Mark stores its address. Mark pointing to there. And then finally, we got another one. That's person over here. And then that's also with age and 67. And then Tom stores its address. Okay, that's about this part here. This part is always the easiest part, okay? Well, you gotta be careful. Hopefully you wouldn't make the same mistake as I did, right? You want to make sure you change the arrow according to the assignments. Let's try. How to deal with this assignment? This means we are copying the address from Mark to Alan so that Alan is going to point to where Mark is pointing to. Agree? Okay, so that means Alan, rather than pointing to here, is now going to point to where Mark is pointing to. Okay? Let's use another color. How about this one here? So now we are changing the pointer for Mark. So that means Mark is not going to point to here anymore. Where is it going to point to? Where Tom is currently pointing to. Right? That's what we have. Okay, so now it should be quite easy. So now when you see Alan, let me use maybe green. So now when we say Alan dot, go to where Alan is pointing to this particular object, right? And then get older. It's going to increment the value from 45 to 46. Okay? So now after that, what we can do the printout. Alan.age, 46. Check. Okay? Mark.age, in that case, 67. You guys were pretty good, but some people were a little bit hesitant. So you want to be definite about the answer. And then finally, Tom.age is going to be also, Tom is here. .age is going to be 67 as well. So the main lesson from here is how you can draw diagrams to trace your code. You do need that in a more complicated scenario. Okay? Any questions? Yes?
So where Alan was initially pointing, that memory is still stored, but we can't access it anymore, right?
That's correct. That's correct. I'll give you another exercise in just a moment. What you were just saying is, you can see apparently Alan is not pointing to this object anymore. Let's say as far as this scenario is concerned, no other variable is storing this address. Yes, it simply got lost track. So now what I would suggest we do one more example, which is completely relevant. You got questions? Yes. Let me just write down the question before I forget. Okay. No. Let me. I'll hold your question first. Let me write down something here. Okay. $45. I'll elaborate on this. Okay, question. Yes, go ahead. You mean if you miss any attributes in constructor? What do you mean? Yes, as we said last time. Let's say, for example, right? Let me go very quickly. Okay. So I guess your question was, let's say we have a constructor like this. We are trying to initialize age, weights, and heights. However, somehow its sense of nationality is missing. So your question might be, what happened to nationality? What happened to it would be it's going to get a default value. So remember, every time if a variable is simply unassigned, it's going to get a default value. Okay, somewhere in the slide, in the review slide, you will see the default value. For example, for integer, it's going to be 0. For double, it's 0.0. For any reference type, it's going to be null. Okay? There's always some default value over there. Okay, yeah. Yes? Yes. Yes, now we're going to swap. This one. Because you gotta, well, somehow you gotta follow the sequence, right? So thinking this way, I'll draw it very quickly again. I'll try to use a highlighter. It depends on the sequence. Originally, Alan was pointing to here, and also Mark was pointing to here, and Tom is pointing to here, right? Originally, okay? So now, if you see Alan is assigned to Mark, that means we are basically erasing this particular link over here, and then now Alan is now going to point to Mark. Okay, that's what we have done so far, okay? And then what happens if you try to do Mark is assigned to Tom, okay? You're only changing Mark, nobody else, when you do a reassignments. So now when you say Mark, rather than pointing to here, so I'm gonna discard this pointer over here, but now Mark is going to point to wherever Tom is pointing to. It's going to be here. That's what it does. Changing Mark is not going to change Alan. Maybe that's your question. But you think about they are independent variables. When you are simply copying address for one variable, it's not going to affect the other. Okay.
A couple questions. So if you switch the order of the assignments, so you mark you Tom and the next line you do Alan.
Sure. In general, the assignments you're trying to perform on the object variables, the order matters. It does matter. Okay, for the completeness, I will do the following. Okay, let me clear up this a little bit. Okay, so it's not too messy. But you can always go back to watch the discussion. The question was, what if I try to swap the order? I'm going to do that. Okay, I'm going to do Alan is pointing to over here. And also Mark is initially pointing to here, and Tom is pointing to here, right? That's how we start, okay? Good. Now you're basically asking, what if I got the following order? Okay? Reverse the order. So now I got Mark is assigned to Tom. And then Alan is assigned to Mark. Okay? So now let's try. What happened to this one? We are changing Mark, agree? So Mark is no longer pointing to here. Mark is right now going to point to Tom. Okay? And now, what happened to the second one? It's going to point to Tom as well, right? Because you can think about, we're going to change Alan, first of all, right? So Alan is not going to point to here anymore. It's going to point to wherever Mark is currently pointing to. right? It depends on the timing, right? Not Mark used to point to, but currently it's pointing to. So now Mark is currently pointing to Tom. So Alan is going to point to here. A very valid and legitimate lab question would be, lab test question. I'll give you these two different orders of the assignments. I'll simply ask you to explain, are these assignments in the reverse order? Are they going to result in the same memory layout? Yes or no? Explain. Right? Okay, I would like to pose this exercise to you, and then we'll do it together. Okay? Okay, so now let me explain what the problem is. Let's say after these two lines, basically again, I got Alan pointing to a new object over here of type person. And then the age is simply just 45. And now I got Tom over here. And then I have age 62, right? Everybody hopefully can do this at least, right? You might have to practice a little bit for the reassignments. Now, what I want to achieve is as follows. This is what I would like to achieve. I want to write a program so that after the program, Alan is going to point to here, Tom is going to point to here. Basically, I swap their value for the addresses. Alan is going to point to where Tom used to point to, and vice versa. You have a solution, you have a question. If you have a solution, hold it. Solution is not important. Okay, it's important, but discussion is more important. You got questions? We got solution. You. Solution. So hold it, please. Okay, hold it. Okay, I have one solution to suggest to you. I have, which may or may not be right. What if I try to do the following? Alan is assigned to Tom. Tom is assigned to Alan. Aha, good. At least everybody would say no, right? That's good. At least we should know why. Oh, you know, what about, that's my solution number one. If you are not happy with it, what about I reverse the order? What about number two? Would it work? Why are you so mean? I just swapped the order. What do you want? So now what's the problem? Anybody try to explain? Please, go ahead. Yes?
The first line will make a point to the other one. The second line will copy where the other one's pointing to, which is itself.
It's pointing to what is currently, but not the old self. Okay? The problem really is let's say for number one, as soon as you do, Alan is assigned to Tom. Alan's new object is already got lost in track, unless we try to have some temporary variable to save it. Guess what? This is exactly the same problem as if you want to swap two variables, x and y. I'm pretty sure you did something like that, right? Maybe either 1012 or 1022. The same problem, okay? So now what I would suggest is, number one, I'll just do one. You can do two as an example. What one would do is simply say, Alan, let me just wipe it out so you'll be clean, okay? Okay, Alan is pointing to here, Tom is pointing to here. Let's say for number one. Okay, let me talk about this. Alan is assigned to Tom. Alan is going to assign to Tom. Now, this object get lost in track. So what we should, so now if we say Tom is simply assigned to Alan, assigning to itself. Okay, let's understand why it is bad. So now, how do we fix it?
Make another reference variable and point it to one of them.
Exactly, that's exactly right. Okay, so now let me do that very quickly. So what we can do now, hopefully that will be the final solution. So now I would say, I declare another one, let's say person, let's say old Alan. How about that? Okay. So what I would do is I'm going to say old Alan is assigned to Alan. And then Alan is assigned to Tom. Now Tom should be assigned to Alan or O Alan? O Alan, right? Let's see exactly how that works. So now O Alan is now a pointer. It's simply going to point to wherever Alan is currently pointing to. And then Alan is changing to point to wherever Tom is currently pointing to, right? Alan is gone and pointing here. You can see changing the address for Alan does not change for O Alan. They are different addresses, different copies, so it does not affect. After that, you'll say Tom is now, rather than pointing to here, it's going to point to wherever O Allen is pointing to. Where's O Allen? Exactly here. So now it is going to point to here. That's going to achieve it. So this hopefully will give you a little bit more flavor about aliasing. Okay? Guys, are we fine? I hope we are fine, right? You know what? Since we are so much into aliasing, let me change dynamically the order of my lecture a little bit, okay? I will get back to mutator accessor when, a little bit later. Let's talk about this aliasing example quickly. Okay, object alias. That's something I plan to do after mutator accessor, but since we are into it, let's talk about it now. Finish that first. So now, let's, yes, go ahead.
Just one last question on that. Can one object point to multiple points?
Can one, okay, your question was like this. Again, we got person, Alan, Sung, New, okay? And also we got person, Mark, also New, and also we got another person, Tom. Okay, your question was, can a single variable like Alan, can it store more than one addresses? That's your question, right? Okay, you're basically asking the same question as follows. If I declare integer I is like a box which can hold an integer, right? Can you store multiple integers in I? The same idea, right? You cannot store multiple addresses in Alan as well. You might think, what about this? If I simply do Alan is assigned to Mark, after that I say Alan is assigned to Tom, would that achieve Alan pointing to both Mark and Tom? No, right? It just get reassigned, okay? Okay, it's a good question, yes.
Could it point to two different things if you use like an array of pointers or something?
You mean, okay, you want to talk about array? We're going to talk about array in just a moment. We will. Aliasing between individual objects may not be too bad as long as you know how to draw. But as soon as we bring collection, like array, into play, the things get a little bit more complicated. But I'll help you with one example, okay? Okay, so what we will do is we'll go back to the slides a little bit. So let me talk about it. So now, before I talk about reference type, let's talk about primitive type for like an integer. Okay, very quick question. You've got I, you got J, right? Now, the way to understand this is, let me just get a new page over here. So now we got I is integer. Let me simply do this. Oh, what did I do? That's very interesting by Apple. How can I get out of it?
Make one of them minimum, like the small, and then just, yeah.
I'm sure it's gonna.
And then,
Oh, interesting. Thank you. Okay. Okay, I gotta be careful. Yeah, I still love Apple, even though it's annoying. Now I lost my slides. Okay, the worst case, I can simply reopen the slide, can I not? Yeah, sorry for the delay. Yeah, I'll try not to do this too much. Maybe I should quit, and then I will try to open again. Okay. I hope it's not going to crash my Mac. I hope. I really hope. I really hope. Okay, so now what do we have over here? Okay, so now okay, so hopefully, okay, I got it back. Okay. Bear with me 20 more seconds. Okay, what I need to do is I'm looking for aliasing. Okay, aliasing is exactly over here. And then I'm going to maximize it. Okay. Okay, after that, get my iPad back. Okay, very good. Now I'll be very, very careful. Good. There we go. Good. Sorry about that. So now let's look at these two lines over here. So now if I just have that, integer I is assigned to 3, and then we got integer j is assigned to I. It's very basic, I know. Why am I bothering you by this? Because the way aliasing works is very similar to that. I want to explain just one more time very quickly, and then we'll do more advanced example. So now, let's say this. Basically, I and j, they're simply just integer variable. So you got I and j. Agree? And then 3 is assigned to I. So we got 3 over here. So now when I say j is assigned to I, what does that really mean? That means whatever that is stored in I, integer value, I'm going to copy that value there and then make a separate copy and put it here. Okay? Now, in this case, for primitive type, it's very easy to understand. However, in the case of reference variable, the situation is no more complicated, just the same. Rather than copying integer values, we're copying addresses. Okay? So now, let's see this. Okay, you can see that very easily. So now, let's see this. Well, this is just another class. Let's say we have a two-dimensional points with just x and y attributes. So now we say point P1 is assigned to new points over here. So now, again, if you say point P1 is new points, something like this. And then we are trying to do P2 is assigned to P1, right? Point P2 is assigned to P1. Let me just mention this. There are two ways to see this. Approach number one. We got P1, we got P2. P1 and P2. And remember the memory we talked about, right? For P1, this is a new object that's stored over here. And then let's say 06001. Currently, P1 is storing 06001. And now I'm saying this assignment. What does that mean? Copy this address value to P2, right? Copy that 06001. So what does that mean? That means both P1 and P2, they store the same address, just the same. Indirectly, they're pointing to the same objects. That's approach number one. Approach number two, which I would suggest you do. Approach number two. Think about P1 and P2 are simply pointers. P1, because of this particular object creation, P1 is pointing to over here of type points. Okay, some object over here. So now P2 is assigned to P1. That means P2 is now going to point to wherever P1 is pointing to, right? So 1 and 2 are equivalents. However, for more complicated code, you would prefer number 2 to trace it as opposed to 1. If you really prefer 1, that's fine. But I'm just saying 2 is easier. Any questions? Okay, that's an introductory slide for aliasing. Now let's do a complicated example altogether. Okay, I assume you're comfortable with, by the way, what's this? Vertical bar, or, okay, and this is n, right? You guys are okay with that, okay? By the way, do you know something called short circuit? Aha, okay. You know what? Let me put it in my notes. Short circuit, I will review that next time. It's also important, short circuit, okay? I'm gonna review that for you, don't worry, Okay? It's good to know and or. However, it's more important to know what's the consequence of using and or, which is more like a logical concept in a programming language. This is something you want to know. Okay, let's do this complicated example. So now you might be quite, okay, this basically I got two versions of, we got two very similar problems. The first one is simply just going to use integer array and then try to print something out. So this one I'm going to leave it to you. It's very easy to see. Okay, this one is not that interesting. If we got enough time, I would have gone over this one with you as well. But let's save some time. What I would like to do is to do this problem over here. Okay, so now I'm going to present the code line by line. But before I do that, I really want to give you the message I really want to give to you is when a program gets complicated, you don't want to think about how things should work just in your head. It's not going to work. For example, what if the code looks like this? 4 objects, 4 new objects. You have an array, Alan, Mark, and Tom. You have another array. And then you try to use a loop with some kind of operation over here. Okay? And then you try to do set age, print line, and etc. Do you think you might be able to answer this by thinking in your head? I cannot. I gotta admit, I cannot. I gotta trace it. Okay? Let's do it together. Okay? I think they'll be worth doing. So now let's do it all together. So can you grab a piece of paper, or if you can, just try to draw line number 1 to line number 4. How should the diagram look like? I'm gonna draw on my iPad as well. Okay, I'll give you 1 minute. Take your time. Make the following assumption. Let's say we only got 2 attributes in the person class. We only got name and age, only 2. That means only 2 rows of your box, okay? Only age and name. Okay, I'll give you another minute. Okay, it's good. It's important to get it right. Okay, I'm almost done. First of all, how many boxes should you draw? 4, right? Okay, because you got 4 new keywords. That's easy. Okay? Okay. Okay, it should look something like this. Alan, Mark, Tom, and Jim, right? 4 different objects of the same type person. You can see over here, I simply got person, 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 person. Each person has name and age, name and age, name and age, name and age. Okay, and then for the first one, it's simply Alan versus Mark versus Tom versus Jim. Okay. The reason we put a title in the box over here is because you may have to draw different kinds of objects. It's not just a single type. We'll see example like this when we talk about aggregation later. Okay, but for now, it's better to put a title. Okay, good. Now let's do the first line. Now this one here, person. Well, can anybody try to read this line to me and tell me what it does? Line number 5. What does it do? What square brackets? You know that, right? Array. Good. At least you know that, right? Good. You're going to create a person array, okay, of how large? Size 3, right? 3 elements in the array. It seems like the first element is going to store Alan, the second element will store Mark, the third element stores Tom. It seems like, informally speaking. Okay? So now, be careful. Okay? I want to do this properly. So now, what I would do is I'm going to put a line over here for you, and then I'll explain it. Basically, I got person array. I'll explain what this decoration really means. Okay, let's make sure this person's 1. Alan, Mark, and Tom. Okay, now it's number. First of all, let's clarify what exactly this decoration really means over here. What does this really mean? But this one is not really about creating the array just yet, right? We're only declaring this is a type. It's not a single person, but multiple persons, right? So now I want you to contrast with this. If I only say person Alan, as opposed to persons 1, person square brackets, what's the difference between these two decorations, right? The number 1, we see that Alan simply store the address of a person objects. Okay, just a single one, right? No multiple. Back to your question, how can we store multiple addresses? Array, okay, or collection. And now this one over here, it tells us it's basically array of person addresses. So now, for example, if you say persons at position 0 is going to refer to one address. Persons at position 1 is going to refer to another address, right? So now let's demystify this decoration over here, or this expression. I suppose you use something similar, right, in 1022. Okay? So now what that really means is as follows. Let me try to give you the equivalent form. This one single line is equivalent to the following 4 lines. Okay? Declare the array, person brackets, that's a person array. And then I would say persons 1. And now I can say new as well, right? I want to create a new array objects. So now I know that I'm going to store 3 things. New person array of size 3. Okay, that's the first one. What that would do is simply just going to say persons 1 is going to point to the starting address of some array of size 3. Initially, none of this stuff has been stored just yet. So what will be the value for each slot? Null, because that's reference type, okay? Initially. Let me just put null over here. Initially. Okay, let me use maybe orange. So now, what would be this one, this one, this one? This corresponds to index 0, index 1, index 2, right? So it would be persons 1 at position 0 is assigned to Alan. Followed by persons 1 at position 1 is assigned to Mark. And also persons 1 at position 2 is assigned to Tom. Okay, these are the 3 lines. So the blue and the orange combined together, 4 lines, is equivalent to this blue over here. Okay, you can do either way. But just easier for me to explain using the blue and orange. Okay, I mean just this part here. So now, question for you. how do we, I already do the blue, which is to initialize this array of size 3. But now, how do I execute the 3 orange assignments over here? What about the first one? What does the first one do, really? I'm trying to copy the address from the first position of the array to Alan, or the other way, right? I'm trying to copy the address of Alan into the first position of persons, right? Persons 1, okay? Let's say, for example, this is Alan objects. Whatever address it has, it's gonna be copied over to here. That means this slot here is now going to point to wherever Alan is pointing to. Don't you agree? Rather than null. Okay? Number 2, similar, persons 1 is now going to point to wherever Mark is pointing to. And now, number 3, persons 2, which is here, rather than pointing to null, is going to point to wherever Tom is pointing to. It's really important to get this right. Guys, questions? If you understand up to now, I think it's about 50% you have understood. More than 50%. The thing that's left is about how to do a little bit for loop, which might be a nice review anyway. Okay? Okay. Question? Yes. You can use the curly brackets, no problem, just one line, if you know what you're doing. Oh, the question was, could you do the following? It's a side issue. If I already got persons array, let's say persons. If I simply say new, let's say person array. Let's say, for example, right? Let's say you were asking, can I, after this line, still say persons is assigned to maybe Alan, Mark, and Tom? Okay, the answer is this will not compile. Okay, here is it's a little bit subtle detail. You can only use this expression over here only on the right-hand side for initializing the array. That's the only occasion you can use. You have to use it when it's first initialized, not when it's reassigned. Only usable in initialization, not reassignments. Okay, it's a subtle detail. I wouldn't really test you on that because that one's not really intelligent, right? Just a compiler decision. However, if you know about this, just make sure if you do got compilation error because you try to use it for reassignment, you got error. Nobody's gonna help you, right? Gotta remember, okay? That's for your own sake, okay? I wouldn't test you on this for this particular detail. Okay, question? Yes?
So this array person is an array which stores the objects of the past person.
Okay, let me go back here. Then I'll go back to your question. Again, for this particular decoration over here, what it does is it's going to be an array of stuff, an array of slots, right? We are saying that every slot is going to be of type person. So that means every slot is going to store the address of some person objects.
It can't store any other class.
You cannot store, for example, let's say if you are basically asking this. Again, the answer is no, you cannot, okay? If I say persons PS is, let's say something like this, okay? Whatever it is. So now you're saying that PS at position 0 is assigned to Jackie, for example. Can you do that? No. Simply because this is of type string, which has nothing to do with what it is expecting, okay? It's a compile time error. However, there's always a however, okay? In general, when you're trying to assign one thing to another, the types must be compatible, must be exactly the same. However, we're going to talk about, after reading week, an advancement topic called inheritance. Over there, you can allow type to be assigned to a different types, given that they belong to the same inheritance hierarchy. You don't have to worry about this sentence right now, but we'll get there in about 1 month time or 2 months. Okay, good. So now let me go back to the original question over here. Okay, now everybody, I suppose you're comfortable with this. Okay, so now let's do a little bit more tracing. Let's see the code. So now we say persons 2 is simply just new person, and the length should be the same length as persons 1. Let's do that quickly. Okay, so that means I got persons 2. Persons 2 is going to point to an array of the same size. Okay, it's 3 elements. And then initially it's simply just going to be null. Okay, that's what we have done for line number 6. What about line number 7 and 8? What's percentage sign? Modulo. Yes, remainder, right? I'm sure that's what you're going to say. Okay. Yes, exactly right. So now, can you just tell me just for the very first iteration? Oh, first of all, okay, let's understand the loop very in a thorough way. You're going to see something very similar throughout the course, so I will cover this slowly. According to line number 7, how many iterations are you going to run for this loop? 3 times. Okay, think about for the very first iteration, I would be 0. For the second iteration, I would be 1. For the third iteration, I would be 2. So far, 2. Okay, I cannot really write on the slides, but what's persons 1 the length, which is 3, right? After the third iteration, I is simply just 2. 2 less than 3 is true, so we are fine. But as you increment from 2 to 3, 3 less than 3 will give you false. That means after the third iteration, you stop. Okay, it's only 3 iterations. Okay, if you are having trouble with understanding what I'm trying to say about loops, watch the tutorial. Okay, that will help you. Okay, so now 3 iteration we agree. So now I want you to think about iteration by iteration. For the very first iteration, okay, let me just help you with that. I am going to try if this will work. If I try to do a snapshot over here, I should be able to paste it over here. No. Never mind. I got to work it out. Okay, let's look at that. And then for the very first iteration, let me write it out. Let me use green. Basically, we're saying that persons 2 at position I is assigned to, I'm going to copy that. Okay, persons 2I, persons I, persons 1, and then what do we have over here? I plus 1 modulo the length of persons 1. I modulo, I would say PS1 for persons 1, okay, just for brevity, dot length. Oh, I plus 1, thank you. And I need a little bit more space. I'm pretty sure this will help me on that. Okay, so now I plus 1. Okay, so now let's try that, okay? That's exactly how you're supposed to trace the code, right? Now I'm not tracing objects just yet. I'm just tracing loop. So now for the very first iteration, I will be 0. Agree? Now I plus 1 will be 1. 1 modulo the length of PS1, which is 3. 1 modulo 3 will give me 1. That means in the very first iteration, I'm doing PS2 at position 0 is assigned to PS1 at position 1. Agree? What about second iteration? It's 1 here, and then 1 plus 1 will be 2. 2 modulo 3 give me 2. Okay? So the second iteration, PS2 at position 1, is assigned to PS1 at position 2. What about final iteration? Are we going to get array index out of bound exception? I heard no. Okay, let's see. Okay, now third iteration, I will be 2. So now 2 plus 1, 3, which is not a valid index. However, 3 modulo 3 will give us 0. So modulo operation is the normal way if you want to go circular among things. Okay. So now that will be PS2 at position 2 is assigned to PS1 at position 0. Okay, that's how we trace the 3 iteration. That's only about knowing what to be executed. Let's execute it. Okay. So now let's say for the first iteration, how do we update the diagram? When I say over here, this guy here, PS2 at position 0 is assigned to PS1. Which pointer are we changing? Are we changing the pointer in PS2 or PS1? PS2. Good. Let's do it. So now I'm going to do green. Okay, so PS2 at position 0 is exactly over here. Rather than pointing to now, it's now going to point to PS1. What would be the way to draw it? Don't draw it like this. That's not going to help you. That's PS1, I agree, but that's not the object pointed by PS1. So now, what PS0 should point to is pointing to wherever PS1 is pointing to, which is this object, agree? Okay, so now this is going to point to this object over here. Please practice. Okay, so now PS21 is now going to point to PS2. PS1, 2, right? PS1 and 2 is pointing to this particular object over here, so it is going to point to over here. Okay, is it possible to think about all this in your mind? Might be if you're very smart. Feel free. That's good for you. Okay. Okay. The final one, PS2 rather than pointing to now, is going to point to PS1 at position 0. PS1 at position 0 is pointing to over here, right? So now this guy here is going to point to here. Okay? As long as your diagram allows you to still follow pointers, you're fine, even though it's messy. Okay? You can do a better job than I do. Okay? That's about all the changes we want to make, almost. Now, let's do one more thing. Persons 1 at position 0 dot set age 70. Persons 1 at position 0 dot set age 70. Let me make sure I got it right. Okay, persons 1 at position 0. Persons 1 is over here. Position 0 is over here. It's pointing to this particular object over here. Set the age to be 70, right? We're setting that to be 70. Yes? One modulo 3 is 1. Yes. Well, what do you want me to further explain for you? Approach me after class, okay? Yeah, maybe you got some little bit of confusion about modulo. Actually, modulo is a very important operator. We need modulo when we talk about hash table, hash code. Guys, if you got a problem with modulo sign, come to me, okay? I'm gonna skip that in the class, okay? Okay, so now we set this to be 70 as we said. Okay, let's try. Now, what would be system.out.println gym.h according to the diagram? Well, Jim is over here, right? Seems to be very innocent, hasn't been affected yet. 0. Very good. What about Alan.h? Alan is this pointing over here, is pointing to this exactly over here, right? It's 70. 70, right? Guys, by the way, I want to say one thing very quickly, okay? So now we do have aliasing over here. I'll give you one occasion. Can you give me all the references, all the copies of the address that is pointing to this particular object, the blue one? How many copies of this particular object's address? How many? I heard 2, I heard 3. You know what? A very, well, I wouldn't say clever, experienced. An experience where it will show you that you don't have to look at the whole diagram. All you got to look at is to see how many incoming arrows. You got 1 incoming arrows, number 2, number 3. So you got 3. Okay? So now what are they? I'll write it down very quickly. So the first one will simply just be Alan. I'll put it here. So Alan is 1, and also persons 1 at position 0, okay? And also persons 2 at position 2. Okay, verify by yourself. Like all these 3 expressions are the same. They store the same address. Okay? Can you see it? Okay. Let me just highlight once more. Okay, so these are very important. Alan is now pointing to here. Okay, and now PS1 at position 0 is also pointing to here, the same objects. PS2 at position 2 is also pointing to this object over here. Okay, that's aliasing. Oh, okay. Okay, I'll stop here and I'll continue on Wednesday.